Supplemental Math videos from Circle Christian School.
Chapter 1 and 2 Study Guide. An easy review is to remember your notes, take a look at your notes, condense key points into 1 or 2 pages instead of having to flip through all the pages. So at the end of the chapter, when you're getting ready for a test, take a few moments, I'm talking 15 minutes, and just go through your spirals and condense key stuff. It's priming your brain. It's getting it ready. There's always a study guide at the end of every chapter. Just before the review exercises, you can look at that. You can fill in little gaps. Remember, avoid cramming. The person who doesn't do well on the tests are the people who just walk in and take them. Prime your brain. Okay, the key to working with any study guide is to start with your notes. So I'm just going to emphasize that all over again. In chapters 1, what we basically did was work with our real numbers. So take a look at those just for a second. Remember to use your order of operation. Remember your laws of equality in here, the commutative property, the associative property, distributive property, the identity properties, and the inverse properties. Next after that is take a look at the 3 steps for solving an algebraic equation. If you follow these 3 steps, I guarantee you'll get rid of any of the silly mistakes that happen. First thing that you always do is start with offensive equality. Order is key here. Sloppiness is what ends up aiding those silly little mistakes. So you start with offensive equality. The next thing that you do is distribute, then combine any like terms on both sides of the equation in the fence there. Step 2, isolate the variable by using the additive inverse. We add and subtract things, get the variable by itself. And then step 3, isolate the variable by using the multiplicative inverse or the reciprocal property. That's when you finally get down to the bottom. The more you work from left to right, the better. That's also very key. First parts of chapter 2 is, of course, this solving part, so you can practice a few problems in there. Just take a look at the review exercises. It's broken up into 2.1, 2.2, 2.3. After that, there are, of course, the word problems, and I'll talk about that in a minute. And then there are the inequalities, and I'll talk about those in a second too. But this page here is really totally for you to get your notes ready. Putting it all in one place will keep you from having to flip all the way through your notebooks and back again and trying to find your own examples. Put down what's key there, kind of the concept. Find a problem that matches it. Work it. Check the answer. If you feel good about working that problem, then you'll do fine on the test. Something that you can use is that concept assessment that I gave to you. Of course, this is the chapter about word problems. So things that I want you to check out is, do you have a system? Do you use something like Buck or the star that I gave you? Labeling is key here. Label, label, label. Make yourself a picture. Block things out in the problem here. Physically write what's going on. Read a problem out loud. Those are all great things. So in this section here, what I want you to do is actually put as many things as possible about strategies and things that you can do to work word problems. Types of word problems that you'll need to know about is the ones that have the consecutive positive integers. Remember that the first number is It could be n, it could be x, but that's the first number. The second number that's consecutive is just one more. So you'd have n plus 1 is your second number. N plus 2 is the third number, and so forth and so on. When you have consecutive, positive, even, or odd numbers, remember it's always two more. Doesn't matter if it's even or odd. They're always two away from each other. So of course the first number is going to be n. The next one's going to be n plus 2. And then n plus 4. So forth and so on. Another thing to know is how to work a percentage problem. Remember, your basic percentage problem works with percent goes first. The of number is next, and it really has an of in front of it. It is the original amount, the total amount, and is, and then there's a part number. It's a part of the original, or it might be even more in the original. It just depends on if it's markup or discount. But it's the result. And it's usually sitting around with is, or maybe the word are. Is might be in front of the number, or is might be after the number. The one that you, again, what you're looking for is put percent first, your of number, which means times, is, which is equal, and then either a discount, a markup, a part of a number. Remember, money also means percent a lot of the times here. When you have things like sales tax, a lot of the times it'll be written as 6.5%. Of course, our calculators can't do that kind of thing, so you have to change it to be a decimal type of situation, so that would be 6.50%. And so to change it into the decimal, you're going to have to jump at two places here. So what you're really using is 0.065. Another thing that you want to really work on, especially if you don't like the fractions, is to ditch that demon. And when you ditch the demon, what you're doing is finding a common denominator, and you multiply each one of the terms by that common denominator. When you do that, what you are doing is cutting out your denominator. That's what you want to do. You're making an equivalent equation that has no denominators in it. All it has is whole numbers, and then you can go and work it. Working with linear equalities, just remember that if you are dividing by a negative number in step 3, that you need to flip that inequality. Again, you're going to start with a fence of equality when you go work it. And you just start with step 1, distribute, combine any like terms. Something that helps with the integer boo-boos is to do exactly what I'm doing here. Circle what you're distributing. Give yourself some arrows so that you have a place to follow. We end up with a negative 6x here, positive 12, minus the 4x. There's our sign, greater than, a negative 2x, and a positive 18. Combining our like terms, we get a negative 10x plus the 12, greater than negative 2x plus 18. Avoid trying to do this in your head, please. They're not always going to be nice, simple, pretty little numbers like this. You're going to end up with complex computations, which what happens in algebra is it's not so much that you're working with numbers and you have to do this, that, or something else. the concept has a process. What you have to learn is the process to a point where, like with your multiplication tables, you know them by rote. So I want to get my variable by itself over on that side. Notice how I'm working from left to right. We're going to take away the 12 and take away the 12. You get a negative 10x greater than the negative 2x plus 6. Now we're going to add the 2x. This is where a lot of boo-boos happen in with the integers. I like putting my plus sign there as opposed to not having a plus sign there. Just helps me out with the integers, and again, helps keep things nice and straight. So we get a negative 8x is greater than the positive 6. Okay, I'm just going to fly this up here. And we're dividing by a negative number in step 3. So we're going to flip that inequality. And so we get a negative 6/8, which is a negative 3/4. Absolute value always has two answers. Whatever happened inside the absolute value here, whatever happened to the x, gave you a negative 5 or a positive 5. So we have to set it to two things. What you have to remember here is looking at the inequality here is going to tell you if you're doing that in between or the outside parts of a number line. The in between is going to give you a is the less than and the less than and equal to, and the ors are greater than and greater than and equal to. They're the ones that are on the outside. So since this is a less than, we know it's going to be the in-betweens. And that's what I'm going to do. I'm going to set it right in between my two values here, my negative 5 and my positive 5. Bring yourself a nice fence down. Okay, we have to get the x by itself. We have to get rid of all addition and subtraction before we can start multiplying. It has a 1 being taken away from it, so we're going to add a 1, which means I have to add a 1 on both sides of the fence. And we get a negative 4 less than the 2x less than positive 6. No more addition, no more subtraction, so we're going to divide everybody by the 2. And we get a negative 2 less than the x less than the 3. And on the number line, it would look like this, negative 2 and a 3. We just need our key numbers, our answer numbers. Since it is a less than without the equal sign to it, it's that open circle thing. That's going to be the parentheses. And all the numbers that would make a true statement are between negative 2 and 3. You can always George Polya it, do the George Polya double check. Find something, put it back inside. 2 times 0 gives us a 0, negative 1. Negative 1 comes out as a positive 1. Is positive 1 less than the 5? Well, yes, it is. So we know we're good. We did the right thing. All right, let's try a couple word problems. Andy has $55 and he's going shopping. He buys a Hang 10 shirt at Ron John's. Oh, my little computer thing. It's Ron Jones Sure Shop. Okay, for $46. The tax in Brevard County is 7%. How much change does he get back? Okay, so the first thing is that we know we've got this shirt, and it's $46. If you don't know what a Hang 10 shirt is, you just totally have to look it up. It was the thing in the 60s to get Hang 10 shirts. We know he also has $55, so that's nice to know. That's what he's got sitting in his wallet. Lucky kid. Wish I had $55 sitting in my wallet. We know the tax in Brevard County is 7%. Our calculators can't do percent, so we're just going to go ahead and change it into the decimal. And when you go shopping, basically what happens is they scan the item. The little computer says, okay, I have to add 7% sales tax. So 7% of the 46, going to do our basic percent setup. The percent thing goes first. The of thing goes next, which is going to be the $46 on the shirt. When you get all done here, you find out that the tax is $3.22. So we're going to add that to the $46. And the cute little cashier says, that will be $49.22, Andy. And Andy says, I have $55. So what is my change? And so, not that there's a $55 bill, I just expected it to be a little bit more than $49, but there was a nice estimate. You know, he can buy himself some little cute hacky sack ball or something. So, we're going to take the $49.22 away from the $55, and you get $5.78. And I'm just going to do a little double check on my math here. Yes, awesome, cool. We got it made in the shape. Next one here is a rectangle is 3 times as long as it is wide. The perimeter is 120 centimeters long. How long is the length of the rectangle? It's always nice to start with a picture. Okay, so we got a rectangle. That's nice. Things that we know about a rectangle is that the width is generally a little bit smaller than the length. So we have a width and we have a length. We're talking about perimeter, so we're walking around the guys. Things that you need to know is a couple formulas, basic formulas, perimeter, area, volume. It's good to memorize just the basic ones. Saves you a lot of time when you start taking your ACT and SAT tests. Although it's sitting there at the top of the one page, flipping back to the one page takes time. You don't have the time. So perimeter, we happen to know, is 2 times the length plus 2 times the width. All right, let's find some other things we know. We have a rectangle that is 3 times as long as it is wide. Okay, we also know that the perimeter is 120 centimeters long. Very good. So I'm just going to put the 120 where the P is. Now, taking a look at the length here, it says the length is 3 times as long as the width. Okay, well, the width is the width, but the length here is 3 times as long as the width. Okay, that helps you avoid having the 2-letter thing, and you end up with just one variable inside here. Very good. So I'm going to go 2 times the length here, which is 3 times the width, plus 2 times the width, which is just W anyway. So we get 6W plus the 2W is the 8W equals the 120. And divide out the 8, and we see the width is 15 centimeters. And therefore, the length would be 3 times as long at 45 centimeters. And again, you can double check. Just add the stuff back together. 15 and 15 is 30. Good deal. 45 and 45 is 90. Good deal. Hey, yeah, it's 120. All right, the evil mixture problems. With mixture problems, honestly, it's you've got a container of something plus a container of the same kind of thing, but just has a different value to it, and you're mixing it all together to make a third container. So as long as you make little rectangle boxes to represent a container for your picture here, you'll be good. You'll understand the setup. Mixture problems have 2 parts to them. They have a physical amount of whatever the object is, whether it's nuts, birdseed, lemonade mixture, alcohol mixture for chemistry, saline mixture in chemistry. Those are kind of the 2 bases that you use in chemistry there. Hamburger meat, any of those candies, whatever. When you mix them together, you're adding, you get a final result. Then it has a percent of something. And that percent is can also be money, because money is a percent. So Joshua Jack's best lemonade is a mixture of 5% squeezed lemon juice with water to a 20% squeezed lemon juice with water. How much of each mixture does JJ need to mix for a pitcher of 10 liters of his best 15% lemonade? All right, again, 2 parts. You got a pitcher, you're making a big pitcher. And that's not in drawing a pitcher, but a pitcher that holds lemonade. And we know that there is a 5% one. And so I'm just going to go ahead and put that in the decimal. There's my percent. And a 20% one, again in the decimal, which would be a 0.2. And it's going to end up being a 15%, a 0.15. Now the amount. All right, we're going to end up with 10 liters in the end. We want 10 liters in the end here. But how much are we going to do with the 5% and the 20%? Well, okay, the first part at the 5%, we're just going to call X. And this is a lot like that consecutive number thing where you are you begin with something and then you're adding 2 and you're adding 2. Well, the difference here is what tells you what's going on with the amount here. And the difference is the other picture, which is going to be 10 minus the X. It's the difference. So it's always going to be the difference. So now we're just going to set up, based on what we're doing, adding the 2 together to get the result. So 0.05 x plus 0.2, 10 minus the x, equals what we ended up with, the 0.15 of 10 liters. Okay, so 0.05x, we 0.2 is going to give us 2, and then minus the 0.2x, sorry, and equals a 1.5. Okay, combining our like terms here, we see that we get a 0.15x, and it's a negative. And a lot of times in this setup, you're going to have negatives on both sides. That's a good thing. If you end up with a negative on one side and not the other, something's wrong with your math. Equals the 1.5. I'm sorry, 0.5. Let me do my whiteout. And it's supposed to be a negative anyway. And then we just divide. We know it's going to be positive anyway. So we end up with 3.333333 because that's what your calculator just told you. Remember, that's just 1/3. 0.333333 is 1/3. So 3 1/3 for the 5%, which means the other amount would just be the difference of the 10 here. So that's going to be 6 2/3. Just think pizza. And there you go. So what you're going to do here at the end is make a word problem for me, one, so I can work it, and two, if it ends up being just a really cool word problem, expect to see it on the semester test, which will be good for you because you've already worked it and you know what the answer is. All right, have an awesome day.